All right, hello, Honors Algebra 2 students. I hope you're enjoying your day so far as much as I'm enjoying mine. Today we're going to talk in this lesson about rationalizing denominators. And so we start here with the initial statement of what it means to rationalize a denominator. The phrase rationalize the denominator means we're going to turn the denominator into a rational number value. And if you remember before, rational numbers are fractions, can be written as either terminating or repeating decimals, but they can be written as a fraction of integers. And so what that means is we need to get all of the irrational numbers out of our denominator. Like, specifically square roots are mostly what our focus is here when we're talking about rationalizing the denominator. So we're going to rewrite these in such a way that there are no radicals in any denominator. Or if I have a radical of a fraction, we don't want any denominators that exist in any radical. Okay? And as we go through some examples, we'll look at some different techniques that we can use to get denominators rationalized. The most basic technique, which we're going to use in this first example, is we are going to, multiply the numerator and denominator of this fraction by some number so that it turns the denominator into something that doesn't contain a square root. So if you think about the way this is going to work, we're getting rid of the square root of 2. Well, what do I need to multiply the square root of 2 by in order to turn it into a whole number? Well, I need to have, the same number of factors, an even number of the same factor in order for the square root of that to be something that comes out as a whole number. So what happens here is if I multiply this denominator by the square root of 2, the square root of 2 times the square root of 2 is just 2. So that will serve to rationalize our denominator. But when we multiply the denominator by square root of 2, we must also multiply the numerator by the square root of 2 in order to preserve the value of this fraction. And so this simplifies to 7 square root of 2 over 2. And now my denominator is rationalized because there's no square root here in the denominator. And you see there is a radical in this problem. There's no denominator in that radical. Okay, let's go ahead and move on to part B. Okay, so in part A, the original fraction was already in, the simplest form. We'd already simplified both the numerator and the denominator before we rationalized. That's something that we want to do in this case. Before we rationalize, let's completely simplify what we have here. And in order to do that, we'll simplify these square roots. This turns into 2 times 3 because the square root of 9 is 3. And the denominator becomes 4 times the square root of y, and so simplifying all of that gives us 3 over 2 times the square root of y. And now what I want to do is I want to go ahead and rationalize. So I'm going to multiply the denominator by what I need to multiply it by in order to get rid of this radical. I have the square root of y. In order to get rid of the square root of y, I'm going to have to multiply it by the square root of y. And so now this ends up becoming 3 square root of y over 2 times square root of y times the square root of y, which is just y. And so there's our final answer. We've rationalized the denominator in that expression. Let's do one more. Now in this one we're starting out with the third root of a fraction. So instead of having a radical in the denominator of a fraction, we have a denominator in a radical. But we're going to use one of the exponent and root properties that we've already learned. We're going to take this third root of 2 over 25, and remember that meant, I'm going to kind of put in a little bit of extra work here, that meant 2 over 25 to the 1/3 power. And then using exponent properties, that meant 2 to the 1/3 over 25 to the 1/3 until, this is equal to the third root of 2 over the third root of 25. Now usually at this point in my life, I would just go ahead and go directly from here to here without showing all of that work in between. Okay, so now our denominator contains the third root of 25. So before we were looking for a square root to multiply by so that we had a square root with the same two factors. Now, if you think about what we've got going on here, in the denominator we've got the cube root of 5 times 5. Well, we need the cube root of the same factor 3 times in order for it to produce a whole number. And so, if we multiply our denominator here by the cube root of 5, that's going to give us the cube root of 5 times 5 times 5, which is going to end up being 5. And then I need to also multiply the numerator by the same thing in order to maintain the value of the fraction. And so now this ends up being the cube root of 10 over the cube root of 125, which is just 5. And there we are with our final rationalized answer. All right, let's keep moving along. Your turn. What I'd like you to do is go ahead and pause the video and complete these 3 problems. And when you are ready to go over the 3 problems, then you can click unpause on the video and you will see the worked out solutions to these problems. So go ahead and pause your video now. And now, just like magic, when you unpause, there are the solutions to the 3 problems that you should have done. Take a moment, you can pause the video and compare your work to those there, and then we will be back and continuing on. All right, continuing on. Some more practice problems for you to do. Once again, I'd like you to pause the video and try and simplify these expressions, and then make sure in the end that you rationalize your denominator. So go ahead and pause your video now and come back to look at the solutions in a moment. All right, and there we are again, just like magic. There are the solutions to your more practice problems here and what those should look like. All right, moving along. The next thing you see is a little box here that defines what conjugates are. If you remember back when we talked about difference of squared, when we talked about factoring, we talked about the difference of squares and that a squared minus b squared was equal to a plus b times a minus b. And that's a very useful thing for us in simplifying and rationalizing denominators. You know, so far we've looked at rationalizing denominators where there was only one term in the denominator. Now, in the next bunch of examples, we're going to look at rationalizing the denominator when there are 2 terms instead of just 1. So this is a very important thing for us. These 2 numbers are what we call conjugates. And what does it mean for things to be conjugates? Conjugates have the exact same 2 expressions on either side of the sign. It's a binomial with the exact same 2 expressions. The only way they differ is one of them has a plus sign and the other one has a minus sign. So for instance, if I said, x plus 2y, the conjugate of x plus 2y has the same terms, except it's separated by a minus sign. So x minus 2y would be the conjugate of x plus 2y. That's what conjugates are. All right, and now let's go ahead. We're going to use some conjugates. To rationalize a denominator with 2 terms, we're going to multiply the numerator and denominator of the fraction by the conjugate of the denominator. So let's go ahead and we'll look at this first example. Simplify the following. So I look at my denominator. The denominator is 2 square root of 5 plus 1. It's a denominator with 2 terms that contains an irrational part. So what we're going to do is we're going to multiply the denominator of this fraction by the conjugate. The conjugate of 2 square root of 5 plus 1 is equal to 2 square root of 5 minus 1. And then in order to preserve the value of the expression, we're going to have to multiply the numerator by that same expression. And now we're going to go ahead and multiply these 2 things out. The numerator, I multiply the numerator of the one fraction by the numerator of the other. So that's 3 times 2 square root of 5 minus 1. And in the denominator, I multiply the first denominator by the second denominator. All right, and now I'm going to go through the algebra to do this. This is going to be 6 square root of 5 minus 3 in the numerator. And in the denominator, I'm going to have 2 square root of 5 times 2 square root of 5, which is going to be 2 times 2 times square root of 5 times square root of 5, which is 4 times 5. That's going to be 20. And then my outer terms, 2 root 5 times a minus 1. Then my inner terms, 1 times 2 root 5, that's a plus 2 root 5. And then my last terms, 1 and minus 1. That's going to be minus 1. Now you'll notice when you multiply two conjugates together, what happens is these two center terms, when we multiply them out, are going to be two terms that are identical, only with opposite signs. And so they're going to cancel each other out. And now we end up with our final expression here of 6 square root of 5 minus 3 all over 19. Or if I wanted to, I could write it as, two separate fractions. But I prefer leaving it here as one fraction. Okay? All right, let's keep rolling. Do another one of those. We're going to simplify the following. Square root of 5 plus 3 over the square root of 3 minus the square root of 2. So we've got an irrational denominator with two terms. So we're going to multiply the denominator by its conjugate. Conjugate is square root of 3 plus square root of 2. I'm going to multiply the numerator by the same thing. And so this is equal to, so this is equal to square root of 5 plus 2, or plus 3, times the square root of 3 plus the square root of 2, all over square root of 3 plus 2, square root of 2, times square root of 3 minus square root of 2. Now I'll multiply these out. Multiply my first terms, square root of 5 times square root of 3, square root of 15. Multiply my outer terms, square root of 5 times square root of 2, square root of 10. Inner terms, 3 times the square root of 3, that's 3 square root of 3. Last terms, 3 times the square root of 2, it's 3 square root of 2. And I can't combine any of those. And now when I do my denominator, I've got square root of 3 times square root of 3 is 3. Outer terms give me a minus square root of 6. Square root of 3 times square root of 2 is square root of 6. Inner terms give me a plus square root of 6. And my last terms give me a minus 2. And so when I combine all of those together, that ends up just being 1. And so my answer here is going to be square root of 15 plus square root of 10 plus 3 square root of 3 plus 3 square root of 2. That's going to be my answer. All right, what I'd like you to do now is go ahead and do the problem here under your turn. You're going to go ahead and do that on your own time. Please take a moment to pause the video, and then, just like magic, once again, the solution will be here for you to check your work. So go ahead and pause your video now and come back when you're ready and you're finished with this example. All right, so there's your solution to this one. You notice when we get here to the end that we've got all these numbers that are divisible by 8 when we simplify, and so I factored an 8 out of everything and canceled to get to my final answer. All right, that's where we're going to stop for this video. We'll come back and do a second video to catch the rest of the lesson. There's not a whole lot left, so the other video will be shorter than this one. So I'll see you when you come back for video number 2. Okay, bye-bye.